in aviation, we discharge the whole battery or a significant portion of the battery every time we fly the aircraft. And aircraft only make money when they're flying. So turnaround time is a very, very important metric. It's driven by charge rate. So if you can't charge it and turn it around in 20 minutes, then it's really difficult for operators to make money. We have that technology. We have the fastest charging cell in the world.
Welcome to Sustainability in the Air, the world's first podcast dedicated to sustainable aviation. I'm your host, Shashank Nigam, the CEO of Simplifying. Every Thursday, I have important conversations with top aviation executives, technology entrepreneurs, and policymakers helping aviation take climate action. Conversations that help separate the signal from the noise. Whether you are a frequent flyer or an airline executive, if you care about sustainability or simply love traveling, welcome aboard. This season of Sustainability in the Air is brought to you by Travelport. Travelport is a global technology firm that powers bookings for hundreds of thousands of travel suppliers worldwide. The company's travel retailing marketplace, Travelport Plus, helps retailers understand and communicate the most sustainable options. When it comes to sustainability in travel, it can be difficult for travelers and agents to identify which flights, routes, and accommodations are the greenest. That's why Travelport empowers its agents to operate as modern retailers of sustainable travel, giving them the ability to access consistent emissions data using the travel impact model. Travelport is also exploring solutions to help travel retailers offer carbon compensation and nature regeneration to their customers. My guest today is a little different from the typical airline or technology executives we have on this podcast. Nathan Millecam is the president and CEO of Utah-based battery company EP Power Systems. He is pushing the boundaries of what lithium-ion batteries can do. Going from 3 to 7% gains in energy density, Nathan and his team are able to turn this into 20 to 30% improvements year on year in battery capacity. For those of you who may have heard my interviews with Honeywell Aerospace CEO Anders Forslund, they would know that it is critical to have high density batteries. Nathan is powering a lot of these future eVTOLs and other electric aircraft by getting battery density up. And I thought it will be very, very fascinating to dive a little deeper into how battery technologies work. And Nathan has no qualms about opening up. Enjoy the conversation. Nate, it's great to be finally speaking with you. You are the first technology founder of a battery company we have on this show and in the book as well. Tell us, what's your background? How did you get into electric batteries for aircraft?
Yeah, it's a great question. So how do you get into batteries for electric aircraft? I think the story goes, my background has been in aerospace my whole career. I graduated from my master's degree in Arizona State University. I was admitted into a leadership rotational program at Honeywell Aerospace. And so Honeywell Aerospace is a major aerospace conglomerate that does a lot of the tier one systems, from propulsion systems to avionics to flight controls to you name it. And so in those rotations, they move you around to a bunch of different roles. And one of the roles they asked me to do was to be a program manager over the development of a independent power system for the flight control electronics on Boeing 787 Dreamliner. And within that suite, you had to have a lithium-ion battery and you had to have a battery management system. And so I got exposed to the technology in the kind of 2006 to 2008 timeframe. Learned a ton about lithium. If you're familiar about the 787 Dreamliner program, they were one of the first, if not the first, the commercial aviation platforms to go with lithium. Had a lot of challenges entering into service, but that flight control battery performed pretty well. So you learn a lot when you do those difficult developments. I could see how valuable the technology was to the industry, particularly as aircraft were really starting to look at becoming more electric, just in its subsystems, but now we're at a whole different scale from them. We're looking at electric as a means of propulsion. And how I got exposed or affiliated with electric power systems. So I went to a power semiconductor company that was doing a lot of advancements in wideband gap technologies like gallium nitride. And we just so happened to buy a battery company that was doing electric motors. And the CEO basically said, "Hey, you know a lot about batteries. Why don't you go see if you can work with these folks?" I met the other co-founder, Randy Dunn, there. Everything that was on my product roadmap at Honeywell, which I thought we were the leaders in the world, Randy already had working, and it was working in automotive and even aerospace applications. So we built a team there. We incubated it for 6 years. And as fate would have it, actually, we did a lot of interesting programs. We did a lot of interesting programs with ground vehicles. We did drones. We did some automotive. And we did some APU start. And essentially in 2014, there was a larger semiconductor company that bought us out. They merged to become like the 5th largest semiconductor company in the world. And we just felt like this product line and this team was something that we wanted to continue. So we formed EP Systems in 2016 as its own independent organization. And really, we've been independent since. It's kind of crazy how it happens. We've just looked at all the design, the flight time, the certification that we've done. I think between me and our founder, we've developed and certified more lithium-ion batteries than anybody in the world.
Wow, that is such an amazingly inspiring story, and what a journey to have met your co-founder and then started something so specific. Now, lithium-ion batteries, correct me if I'm wrong, are the same ones that are used on Teslas and are the same ones that are used in a lot of different type of vehicles around the world. Why the focus on aviation or eVTOLs or drones for that matter?
Yeah, it's a great question. So why aviation for this technology? So a couple things that a lithium battery or more advanced chemistry battery does for you is they're power dense. And so when you ask for power, you can get it very rapidly, very efficiently, and it really becomes a great source. Traditionally, it's been used for things like, let's crank an engine using an APU start battery. But now as energy density and power density has made significant advancements over the last 10 years, well, now we can start thinking about using these things for propulsion architectures. And so one of the first programs we did when we were independent was working with NASA on the X-57. So whenever NASA wants to do something new and creative, they make an X-plane. And so this X-plane was trying to demonstrate distributed electric propulsion. It was also trying to mature batteries. There was a lot of gaps in the certification space of how do you certify a lithium battery, particular propulsion battery. And we made some significant achievements in terms of advancing energy density at the pack level. Because what most people don't know is, yeah, there's a cell, it's energy dense, but I have to put thousands of them together. I have to put them at high voltage. I have to manage them in unique environments. And I also have to manage failure conditions. So one very, we'll call it infamous failure condition is thermal runaway. That's a nice way of saying batteries catch on fire or explode. Well, in an aircraft, we have to manage that. Safety is number one. We have to make sure it's contained, but we also have to make sure that we're still providing power to the motors so that the aircraft can safely land. So energy density at the pack level is everything in aviation, and that's really what we specialize in.
I mean, this is incredible, and I'm glad to hear about this specialty that you have already built up. You, of course, have a lot of eVTOL partners, for example, Plana, SkyDrive, and Supernal. Talk to us a little about both the challenges and opportunities when it comes to eVTOL battery production specifically.
Yeah, that's a great question, Shashank. So production is an important word because we've been doing development to prove that the technology is viable for the last 8 years. And the good news is it's viable. We can see a path to it certifying. Production really is a completely different problem set. And what's interesting, when you start your journey, you think that just the technology maturation and proving that it works is the hard part. Our experience is Production is actually much, much harder, because when you start to look at eVTOLs and you look at a battery now being a propulsion battery, the scale at which we have to produce these things is an order of magnitude higher than anything we've ever seen in aviation. And aviation is not going to alleviate its requirements for safety or certification down to automotive levels or other consumer levels for batteries. So we have to rise to those standards while rising with the production rates. And so some of the unique things that we have to do is, usually in aviation, to prove that it's airworthy, there's a lot of testing, there's a lot of inspection, there's a lot of data collection that has to happen. And it's not just for one cert authority. It's not just the FAA alone. There's a unique element in aviation where the cert authority reviews your data. They have skilled engineers across the table, and they want to make sure it's safe for their flying population. And so you see a lot of variability even between Europe, the US, Japan, and even China. And so when we build something, we are proving that that unit is meeting the high standards for every cert agency that's out there. And then we have to do it at scale. We have to do it at cost. And then we have to make something that's highly reliable and repeatable.
Wow, definitely not an easy road here. And thank you for detailing. You're also developing batteries for electric and hybrid electric aircraft companies like Ampaire and, I believe, REGENT's sea gliders. Tell us a little bit more about that, and how is that actually different from eVTOL battery production?
Yeah, it's a great question. So first, just to tell you a little bit about it. First and foremost, we are thrilled to be a part of these companies' vision. So a lot of the reason why skilled engineers come to EP Systems and how we even recruit them is we always tell them, hey, if you go to one company, you work on one propulsion system. And you'll follow that through your whole career and you'll certify it. If you come to EP Systems, you get to work on everybody's propulsion system and you get to see what the entire industry is doing. And so what I love about Ampaire and REGENT in particular is there's an element of pragmatism that's mixed with innovation. And what I mean by that is revolutions happen in aerospace by incremental evolutions. And so when you look at what each company is doing is they're taking a meaningful step forward to push where the industry is going while staying within the bounds of the CERT framework that we have. So in Ampaire's case, they're really focusing on hybridization or a parallel hybrid. It's a very complex hybrid architecture, but it has incredible gains in weight, and it's very reliable and has a lot of redundancy and safety. So really brilliant architecture, but they're doing it on a Caravan. So the Caravan is a legacy platform. It's certified. It's got a lot of the kinks worked out of it, so to speak. And so really that allows them to integrate at integrated propulsion as well as interface to that aircraft level. Where Billy, what they're doing at REGENT is also very innovative. They're doing a distributed electric propulsion system, but they're doing it in sea gliders. So sea gliders are certified under the Coast Guard versus the FAA. So that allows them a faster path to market. So great step forward. Now, difference between electric and hybrid electric, usually in aerospace, the battery is different. But one of the unique elements of our intellectual property is to really design a battery module that is common, that can go across hybrid applications. It can go across all electric applications. It can be used for power. It can be used for energy. And it sounds like a simple idea, but it's actually really, really hard. Batteries want to be customized. They want to be tailored to those missions. But if we can inject something that's standard, what that allows us to do is allows us to use economies of scale across the entire industry. And why that's important is we have to get the economics to close on this. I mean, we're big believers in this sustainable space. We know we have to make advancements as a society, but our belief is that will happen faster if we give economic arguments to the market to say, this is a better technology than what you have today. It's better than your thermal engine.
So let's talk about economic arguments for a minute, right? We've talked about technology. What is the economic argument? I mean, batteries are heavy. Batteries need to be charged to carry their own weight to take off and then to land, and you have to carry all that weight around. Why and how do batteries make economic sense compared to the other technologies out there?
Yeah, that's a great question. So I'll compare it to one of our launch platforms. It's a flight training application. And this is a really needed space for innovation because right now we're struggling just to get pilots to keep our existing aerospace system flying and our transportation system going, let alone, hey, let's add thousands and thousands of eVTOLs to the skies with a whole new generation of pilots, right? So we got to be able to train the pilots efficiently. The biggest barrier to becoming a pilot is the cost, and it's the cost per flight hour. So you start to break down, like, what is in the cost of a combustion engine today? Well, what most people don't know is every 2,000 hours, you overhaul your engine. And that sounds simple, but when you look at the cost, if you can imagine every other year for your automobile, you had to buy an entire new powertrain for your automobile, well, that gets really expensive. And then when you start to add that with gas, you start to add that with insurance and all these other elements, your cost per flight hour goes up exponentially. So the advantage of an electrical system is they're very reliable, and electricity is a very affordable source of energy. And so what we're actually seeing in our minimal viable product is we're seeing about a 40% cost reduction in the cost per flight hour. Now, your range is going to be impacted because you're right, they're heavier than fuel. They're always going to be heavier than fuel, but they're light enough right now where you're still seeing enough operational range that is useful. So really, we cover about 95% of all flight training missions with the current generations of batteries. Our batteries are designed to be upgradable, so we'll have a more energy-dense solution in 2024 than what we're putting out in the market in 2023. But then once we release Epic 2.0, that actually gets us to 100% of all flight range or all flight training missions at the equivalent cost.
Thank you for highlighting the difference between just the absolute cost versus flight, cost per flight hour. And I'm glad to learn that the cost is coming down and it's become much more manageable because it has to operate in an economically viable way for it to scale. Now, turning to the investment by JetBlue Ventures, can you tell us a bit more about how that came about and how you work with both JetBlue Ventures and JetBlue the airline?
Yeah, great question. So we got introduced to JetBlue Ventures during our last fundraising round, and there was a lot of synergies between our two organizations. JetBlue Ventures is one of the pioneers in aerospace venture funds, and they really pioneered it and showed people how to do it well. And so we feel honored to be a part of their portfolio, number one. But the value element to the airline is really twofold. So right now there's a huge discussion going on in sustainability. And how do you make our current airlines and our transportation systems in the air more sustainable? And a battery is a very, very key technology to doing that, depending on, multiple use cases. You can see battery technology needed. What's interesting is as you start to look at the all-electric and the hybrid electric case scenario, batteries really transition to your new fuel source. And right now, because the fuel source is one of the primary operating costs of the airline, the ability to manage and control that is very, very important as we transition to all electric or hybrid electric architectures. And so really that was the synergy, is to say, hey, we want to go sustainable. We know we need to go there, but unless you have a battery system that not only meets the very high safety requirements as well as the technical requirements in terms of weight, power density, cycle life, and the economics, well, you really don't have a sustainable solution, right? You just have a artificially sustainable solution that may be optimizing carbon emissions, but it's actually forcing us all to travel at a higher cost. And so one has to really question, do we really get to a long-term sustainable environment if we're all having to pay more for things that we use today? And our argument is that's going to be tough. That's going to be tough for all of society to adopt it. And we'd rather not have society make those trade-offs. We'd rather say, well, let's just do both. Let's make it cheaper and let's make it sustainable.
Thank you for sharing that vision. Now, as far as I recall, JetBlue, the airline, does not have any electric aircraft on order. Are you doing any work with the airline itself?
We continue to talk to them about their sustainability roadmaps, but that's probably a better question for them, Shashank, to answer their roadmap questions than have me answer it for them.
That's fine. I've been speaking with Sarah at JetBlue, and she'll be on this podcast and featured in the book as well. Now, if we look beyond just JetBlue Ventures and go global, as you'll be aware, there was a 500 watt hour per kilogram battery that was recently announced in China. The claim is this battery can be used to significantly extend the range of electric aircraft. When it comes to batteries, what is the realistic limit if we look ahead to 2030 or 2035? And what is your research showing?
Yeah, it's a great question, Shashank. So I'll try and start with the simple. So let's just use energy density as our figure of merit, because that's the first one most people go to is, can I, rudimentarily, I'll just say, can I cram enough electrons in 1 kilogram and then pull them out and use them in a format that can actually close a business case, right? Which really what watt hours per kilogram is. So we've seen steady improvement of around 3 to 7% per year over year in energy density. And you continue to see that. We are starting to push some of the boundaries of what traditional lithium-ion chemistries can do. And what's interesting about some of these more advanced chemistries, you see really innovation all around. You see innovation on the electrodes, you see innovation on the electrolytes. And so you start to see these little jumps starting to happen of 20% or 30% incremental improvement year over year. I don't know if it's realistically to think that you'll see that every year a 20 or 30% improvement. But as you start to move to different chemistry families, you'll see those gains, and then you'll kind of continually see those curves continue. So we're very optimistic about the future. Now, to complicate that, where some of the challenges are is energy density is not the only figure of merit that matters in a battery. And what most people don't know about batteries is their energy density varies depending on the rate that you pull electrons out of that battery. And so you might look at it and say, wow, that's 500 watt hours per kilogram. But when you really look at it, they're just discharging it really, really slowly so that they can get every electron they possibly want out of that. Where if you were to ask for power at a higher rate, which is more what aerospace generally needs, is higher power than automotive, then your effective energy density goes down quite a bit. So not only do we need energy density, we need power density. The other figure of merit that's really important for aerospace batteries is cycle life. Cycle life is ultimately what closes the business case. If it only lasts 50 cycles or 100 cycles, you're retrofitting your airplane every other week, and you can't close it that way. So the good news is there's been energy dense cells around for a very, very long time. We filled packs with 400 watt hour per kilogram cells. The continual growth that's needed is not only in energy density, but power density and cycle life. But what's encouraging about the announcement that you're referencing is you're seeing some of the largest cell assemblers in the world start to take notice of aviation. And that's a very encouraging data point, because people who truly produce at scale don't start looking at these things unless they see the raw materials, which really where a lot of the innovation happened, now being for sale that they can buy at scale and they can put into their very large factories. So I think that's the encouraging part, is you're actually seeing the manufacturing readiness level start to become commensurate with the technology readiness level that's been around for some time.
Well, thank you for differentiating and highlighting those three aspects. I remember back in the day, Tesla ran an experiment where if you went at full speed for a Tesla at the insane mode when Elon Musk launched it, the entire full battery would be drained in 25 minutes. So I think that's exactly what you're talking about, the rate of discharge being higher for aviation. You're going at a much faster speed. You're depleting the battery much quicker as well, and hence that results in the cycle.
Yeah, that's exactly right. And then the other side of that too, that's maybe unique to aviation, is how fast can we charge it? So I have a Tesla, and I can drive it all day long, and I can charge it all night long, and it's just fine. Fits my use case perfectly. But in aviation, we discharge the whole battery or a significant portion of the battery every time we fly the aircraft. And aircraft only make money when they're flying. So turnaround time is a very, very important metric, which is driven by charge rate. So if you can't charge it and turn it around in 20 minutes, then it's really difficult for operators to make money. We have that technology. We have the fastest charging cell in the world. We can do that to 3C, but most importantly, we don't degrade our cycle life as a result of that fast charging mission. Usually fast charging just takes what would normally be 1,000 cycle cell and bring it down to 20% or less of what it's actually rated, because you're always being very abusive to the cell to try and get the operational performance that you need.
Right. Wow. That's very well explained. I remember speaking with Greg, who's the founder of Harbor Air. And if you recall, they have been running the electric Beaver between Vancouver and Vancouver Island to Victoria. And they've been testing the battery. And I remember him sharing that to charge the battery, ultimately, for every 10 minutes of charging, he's going to get 20 minutes of flying time. And because his flights are 35 to 40 minutes, guess what? The turnaround time when the plane lands, passengers are getting off, getting on. Within 30 minutes, he has 1 hour of charge. And that's enough for him to go back and then come back. For your high-speed charging, what kind of ratio are we talking about when you say turnaround time, because it matters to airlines a lot?
We're targeting about a 20-minute turnaround time for a battery that's been depleted 80% state of charge. And we're actually very familiar with that Harbor Air application. Those were actually our batteries that we supplied to them.
There you go.
That was a Gen 1 product, and we're really appreciative of people like Harbor Air who started to adopt it, started to learn from it, because that really starts to drove future generations. Right now, we're putting Gen 5 into production, into certification, but you learn a lot every single one of those generations, and certainly that feedback that Harbor Air uncovered was crucial to guide our future technology developments and our product developments.
I'm very, very glad to hear that as well. Now, in the climate technology world, the use of lithium, as you know, is sometimes controversial because of mining or labor issues based on where lithium is being sourced from. Are you looking at alternative battery sources such as graphene as well?
Yeah, I mean, absolutely. So maybe to break down your question in two elements. So graphene is an interesting element. I would put that in what I would call the alternative materials solution bucket. Because right now, if we say, hey, we either have bad places that we source from, or the cost is starting to go up, and we don't have security supply, right? So those are the problems that you're trying to solve. So one way is to say, well, let's change the materials. Let's get away from cobalt. Let's get away from graphite. Let's look at things like composites, or let's look at things like silicon, because they're everywhere and we can get them domestically. So that's a great, very interesting approach and interesting solution, particularly if those materials offer better cycle life. They reduce the cost of the battery, but most of those advanced materials are still in development and still being experimented with. Another solution is we'll build domestic sources and expand the supply chain and control the supply chain. And there's a lot of investment both in Europe as well as in the United States with the Department of Energy to really have an independent domestic supply chain that can provide lithium, that can provide graphite, can provide cobalt. I can weigh in on my thoughts. These are complex problems. It's an extremely complex problem. And doing this for more than 20 years where you make a career out of solving complex problems, I think you need multiple solutions. Usually that's the best way to solve a complex problem. And so I love that people are going in alternate materials. I think that's a fantastic track. I love that we're having independent supply chains, because the reality is usually where things will land is probably only so much of the market can adopt an advanced chemistry with an advanced material. There's likely always going to be a market for cobalt and lithium and traditional chemistries. And so having both really gives us the flexibility to solve some of those big, difficult issues.
I'm glad to hear you have these issues at the back of your mind as well. Thinking larger scale, there are electric aircraft developments going on from Heart Aerospace in Sweden to, you've got the likes of Archer and Joby in the United States. We're looking at eVTOLs that are electric powered as well. What initiatives or regions are you most excited about in general in the industry, and what gives you the most hope about the future of sustainable aviation?
So just to clarify your question, Shashank, like what projects are we most enthusiastic about in
And then what gives you the most hope? Yep.
That's a great question. Well, I don't know if I could pick one. I think I'm enthusiastic about all of them because I think they all have a place. I know sometimes media wants to show that they're competing visions, but working with every single one of these folks, I really see them as complementary. So the urban environment is a challenge. And really, when you look at what eVTOL is trying to solve is an urban environment problem. And that's great. If we can decongest our cities, we can move people, we can move things faster, cheaper. We can create more productivity as a society. And that's fantastic. But when you start to look outside the urban and you look at things like, well, not everybody lives in an urban environment. And if you look at COVID, there was actually a lot of people who moved out of the urban environment. They didn't move too far. They still have a need to get back to that environment, but not as frequently as perhaps in the past. And we see hybrid remote work. We see remote work being available. And so when you start to look at fixed wing technologies, for example, so this is more what Ampaire, or you start looking at another customer, Volt Aero, is looking at very close. This really starts to feed into the urban environment as well from the suburban or the outlying communities. And that's a big deal as well. That's a really great vision. So we're in Logan, Utah, which is about 60 nautical miles from Salt Lake City Airport. Not too far, but when you look at how long it takes us to get there and the cost, a fixed wing is really the optimal solution for more of those extended routes than something within the urban corridor. I also love the logistics missions that people are doing as well. So these are the Elroys of the world. What's a big deal about that is when you start to move goods faster and cheaper, well, now you provide societal benefits of healthcare is a great example. A lot of healthcare is very localized to the urban environment because it's hard to push advanced medicines like cancer treatments, transplant of organs, things like that, because the supply chain is so short from the sort. Well, that enables you to elongate the supply chain. And so now you can put healthcare to where the people actually are. Huge benefit for third world countries, huge benefit for our existing Western countries. So very, very enthused about all of them. I could keep going, Shashank. I could go into the military mission as well, but it's incredible what these things do for the men and women that keep us safe as well. Most people don't know, but we lost a significant amount of people in Iraq and Afghanistan because of protecting fuel lines. And the minute you eliminate those fuel lines, boy, you can save a lot of people's lives, and you can do a lot in defense through domestic or through electrification. So I'm sorry that was a long answer, but I'm just enthused about what this does for the entire world.
No, absolutely. In fact, that little point you touched, the fuel lines disruptions were one of the key reasons for casualties for Western forces in war zones, typically. So if we can solve that, then why not? Finally, you definitely are passionate about the industry. You know the science of it. What gives you the most hope? What is it that you're seeing that gives you the most hope about the future?
Oh, well, you see a lot of things that give us hope. The technology closes. I think that's really encouraging. I think the other thing is we can see the business case close. We see capital that's been aligned. We see a lot of people doing this, and that's great. And you see generally people focusing in the right areas and solving the right problems. Aerospace is one of the most challenging industries that's out there. It's an incredible engineering problem, and it takes incredible intellectual horsepower. It takes incredible financial horsepower to do it. And we really see all those things lining up to make a lot of these visions a reality. So it's hard to point to just one thing. And the nice thing is when you get momentum in an area like this, you mentioned cell technology earlier. That's one data point that makes you excited per our previous conversation. But when you start to see people applying these technologies in different ways that that really provide a great benefit to our populations, and you can see it closing. It's like momentum continues to build, and you see it expand, the innovation, you see the capital expand, you see the progress expand. So I think there's enough momentum right now. It'd be very, very difficult for this to stop and not see success.
I'm so glad to hear. I see this momentum now as well. I see the entire industry coming together. I've had, like I said, Harbor Air CEO. Previously, I've had Hart Aerospace CEO on this show, on the podcast, and I get the same feel. It's not just electric that's making progress. I think it might be the soonest that we see, but also other technologies. Actually, on that, I have a question. When do you think we'll be first able to step on board a fully electric plane?
Yeah, so next year, I think, is the short answer. You'll see a lot of people certifying. Now, for us, it's flight training. So we'll see a lot of pilots who will start flying electric airplanes. You'll see some early adopters in some countries that have less stringent certification requirements happening VTOL. But and then fixed wing, there's a number of fixed wing folks that are also on track in the next 2 years and 3 years to be able to start jumping on electric airplanes.
Wow, I'm looking forward to that day. I'm actually looking forward to trying it sooner than later. Now, the final part of this interview, Nathan, is what I call the rapid fire round, in which we get to know you a bit more personally, and we'll start with something simple. What's your favorite airline?
My favorite airline, well, I should probably say it's JetBlue right now, since they're an investor, but they don't fly a lot out of Salt Lake. So if Amy, you could get on that one, I'd really appreciate it. But yeah, they're probably one of the better ones that we've worked with.
Indeed. What's your favorite book?
Well, that's a tough one because there's so many categories. You could go educational, you could go religious, you could go entertainment.
Okay, let me help you out here. What is the book that you love to gift the most?
I love to gift the most. Well, this is going to be uneventful, Shashank, but I gift to my leadership team whatever it is we need to collectively learn. So lately, I gifted a sales and operations planning book by Robert Stahl. I love a book by John Doerr of Measure What Matters Most. So that's really the OKR discipline. And then there's another book I just read recently that was by Michael Stanier. It's The Coaching Habit. He's Canadian, fantastic author. I probably really like Michael's book.
Okay, I've just finished reading one, actually. It's called Smart Brevity, which I'm actually recommending to my team. It's by the founders of Axios and Politico, and it's about how can you communicate the most by saying less and be concise. Highly recommended as well, based on the genre you told me about.
All right, I'm looking it up. Smart
Brevity, yep, and there you go. What's your favorite city?
My favorite city? That's a good question. I can't pick one. I like rural and I like big cities. So I love rural Logan, Utah, where we're at. There's skiing, there's mountain biking. It's about 150,000 people. So it's got a great feel to it. Big cities. I love Toronto. I like London. Washington, D.C. is probably favorite in the United States.
Okay.
City.
Interesting. Favorite movie?
Favorite movie? I don't have a favorite movie. I kind of go back to the old comedies in like the 90s or the 2000s where I was in high school. So you could go with like anything from Chris Farley, like Tommy Boy was pretty funny. Dumb and Dumber was pretty funny. You know, some of those like
Jim Carrey, huh?
Jim Carrey, yeah.
Okay. What is something you still want to learn?
Oh, well, I'm a pilot right now. So right now I'm trying to expand into instrument training. So I'd really love to expand my knowledge base into that.
Very nice. Glad to know. What do you do in your free time?
Free time, I have 4 children, so and a wonderful wife. I love spending time with them. They demand my time in a great way, so I spend a lot of time from skiing to whatever the kids' extracurricular activity is, I seem to spend a lot of time with those.
I am in the same boat. I've got a couple of young kids, and let's just be honest, we have no free time between work and kids and family. So what are you talking about? And final question, actually final two questions. Who do you look up to?
Who do I look up to? Well, I look up to a lot of people. I've recently had a few folks that have become mentors of mine that really, really have taught me a lot. On the strategy side, get a chance to interface with Dennis Muhlenberg. He's the previous CEO of the Boeing company. He's very much a people-oriented person, very strategic thinker, really, really interesting individual. He'd be embarrassed if the second one, he's going to be embarrassed by me calling out his name, but Tim McLevish, Tim was our CFO for a while, but he was the CFO of a number of publicly traded companies, from Walgreens to Kraft Foods to I even worked at Carrier at UTC for a while. And I really, really look up to how Tim thinks about the world as well as Dennis. I think it always, when you get to be around that caliber of individuals, you can't help but want to learn more why they think that way and how did they get to that. So those two definitely look up to.
Thank you. And finally, what's the best advice you received?
Best advice I ever received. Well, that's hard. I'll go with recent advice, if that's all right, Shashank. And so this actually I'll take from, this is from Dennis, who gave the advice. And it was interesting where he brings up these moments that we have in our careers where you're facing a really difficult challenge, really, really difficult challenge. And it happens to us all the time, particularly in this new aerospace arena where we're solving challenges that have never been solved before, that couldn't be foreseen. And you're trying to do it on a budget. You're trying to do it on a schedule. You're competing heavily against others. And so those moments can be quite intense moments. And the advice it received was, usually in difficult moments like that, the natural tendency of we as human beings is to kind of entrench internally. And particularly if we've been successful in the past and we've been successful individuals, we want to individually solve a problem. But the advice was to resist that temptation, that the best solutions come by reaching outwards, by collaborating with others, by we have a value that we actually call sustainable solutions. And under that value, we say when we're creating sustainable solutions, you have to look at your bias. You have to inject diversity of thought into the conversation, and you have to have good data. And if you can bring all those things together, then 9 times out of 10, you'll find a solution to whatever difficult it is you're facing.
I love it. I love the holistic approach. Let's not go with our own biases only. Thank you, Nathan, for the technical deep dive into battery technologies, on why we should be excited about flying electric in the future. And thank you for opening up and sharing all the good work you're doing in bringing electric aviation to life. It's been a pleasure speaking with you, Nate.
Thank you very much for having me, Shashank. Really enjoyed the conversation.
Thank you for listening to this episode of Sustainability in the Air. Aviation is one of the hardest to decarbonize industries, yet there are multiple paths to get to net zero. Awareness is key to a green future. So please give us your support to help our sustainable aviation insights reach a wider audience. You can do this by sharing this episode on your network, on LinkedIn, Twitter, or even WhatsApp. Or perhaps you might consider leaving a review on Apple Podcasts, Spotify, or wherever you listen to this episode. You can start a conversation with us by writing to us at podcast@simpliflying, that's simply with an i.com. And for more content on sustainable aviation, please visit our website green.simpliflying.com and join the movement. Sustainability in the Air is an original podcast by Simpliflying. The show is produced by Juraj Toth in Slovakia. Dirk Singer is our Director of Sustainability, who leads research for each interviewee out of Greenwich, UK. Shubhadeep Pal is our supervising editor based out of Mumbai and Singapore. The articles are written by Ayushi Badola in Dehradun in India and Meera Hull in Montreal, Quebec. Creative design is led by Lihia Esteve in Montreal. Baiba Dreamliner is the project director for the show based out of Valencia, Spain. Special thanks to Wendy Sim in Singapore. And I'm Shashank Nigam, the CEO of Simplifying and your host. Please feel free to connect with me on LinkedIn.